All right, so next we're going to look at the total displacement of this. And as I was copying the graph over to the next page, I noticed that I put x equals 0 right there. That's pretty silly. Obviously, it's x equals pi over 2. All right, so now we're going to think about the fact that we just did displacement, and that's the easy thing. You just do the integral of velocity. For total distance, integral of absolute velocity, but as a practical matter, we're going to split up the velocity integral into positive and negative parts. All right, so what that looks like for this particular problem is the total distance is going to be, so here's a positive part and here's a negative part. So we're going to divide the limits of integration, the interval, from 0 to pi over 2. Of our velocity function, which is 13.2 sine of 2t dt. Make sure your notation is complete at every step. And then I'm going to put minus, because this part is negative and I want it to be positive, the integral from pi over 2 to pi of 13.2 sine of 2t dt. So you can do clever things like factor out the 13.2 or something like that. There are lots of different approaches you can take to evaluate it. What I'm going to do is just do those two integrals separately. So I'm going to call this one 13.2. So I'm going to factor out the 13.2 and do the antiderivative at the same time. But especially since we already know what this antiderivative is, it's the same antiderivative as before. So that's antiderivative is negative 1/2 cosine of 2t. And we're doing that from 0 to pi over 2. You know, I could have factored out the negative 1/2 in the same step. I chose not to. Minus the 13.2. I think it's clearer if I don't. If I leave the, this is clearly the antiderivative of that in there. It's a little bit of a judgment call. So then this is negative 1/2, same antiderivative here, cosine of 2t. From 0, this one's going to go from pi over 2 to pi, right? Pi over 2 to pi, pi over 2 to pi. So 0 to pi over 2, that's here. Pi over 2 to pi, that's here. All right, so now we'll just go through and calculate those. So again, I'm going to factor out the 1/2 and have negative 6.6 times cosine of 2t from 0 to pi over 2. So all I'm doing in this step is factoring out the 6.6 and factoring out the negative 1/2, really. So then this is going to be plus 6.6 cosine of 2t from pi over 2 to pi. And then, so that's going to be negative 6.6. I really should have equal signs at each step here. My sentence has lacked a verb until now. All right, and then so cosine of negative pi over 2. Sorry, what am I doing here? I'm doing 0 to pi over 2, right? Oh, because it's cosine of 2t. All right, so when I put in the pi over 2, I'm going to have cosine of pi, which is negative 1. And then I have minus for the fundamental theorem. And then I put in the 0, I'm going to have cosine of 0, which is positive 1. All right. And then when I get over here, I'm going to do cosine of 2 pi, right? It's pi in here, so it's going to be 2 pi. So cosine of 2 pi is positive 1. And then minus for the fundamental theorem. And then when I put in pi over 2, I'm going to have cosine of pi. Cosine of pi is negative 1, so negative 1, boom, boom, boom. Notice how I didn't need a calculator for any of this. This could be a calculator inactive question on the AP exam easily. All right, and then so this is negative 2 times positive 6 times negative 6.6, which is positive 13.2, and then this is also 13.2. So my total distance traveled is 26.4. So total distance traveled always has to be positive or 0, and the only way it could be 0 is if the object didn't move at all. All right, that's the only way total distance could be 0. So total distance has to be a positive number or 0. And you get a little bit more insight into what the piston did as a result of this, because this 13.2 and this 13.2 are just these areas right here. And so what they represent is the distance that the piston went out and back. So we now know that this piston went out a distance of 13.2 meters. Boy, that's a huge piston. And then it comes back another distance of 13.2 meters. Somebody didn't think very carefully about their problem when they were setting this up. What kind of a piston goes 13 meters in either direction? Maybe it's some kind of gigantic steam engine of some sort. All right, anyway, there you go. That's finding total distance. All right, so the next thing I'm going to do is I'm going to jump to the book. This is in chapter 7. I'm going to look at page 386. I'm going to look at these graph ones. So one of the things that the AP exam loves to do, as you've now started to realize, is not give you a function for what you're trying to analyze. They just give you a graph, like that's what we're looking at here in 17 through 20, which are going to be part of your homework. So I'm going to look at one of those next.